Good morning, students. Good morning, students. Today we read about the reflection of a light. So this is the part of a 10th class of a chapter light. So this include reflection of a light, refraction of a light, scattering of light, and dispersion of a light. So we study here comparative study also. So first of all, what is light? Okay, so first of all, light. So light is basically what is that is form of the energy which produce sensation. So this is form of energy. So that produce sensation. So basically, light travel in a straight line. Travel in straight line. And light is the form of what is electromagnetic nature. Light is electromagnetic nature. So when we represent light, that is light we represent in form of three components, that is electric field and magnetic field and a wave that travel in forward direction and component of that perpendicular to electric and magnetic field. So these are the basics characteristics of the light. And one more things, when light travel in a straight line and we put object in the way of a light, so what they produce? Shadows. So basically light produce what is shadow. So here we study what is reflection of a light and refraction of a light, scattering and dispersion of a light. So before this we study about what is luminous object and non-luminous object. So first of all, so this is luminous object and non-luminous object. So basically luminous object, that object which produce light. So that is known as a luminous object, and non-luminous object which do not produce light, that is what is non-luminous object. So for example, like table, stone. So these are what are non-luminous object. And example of a luminous object, what is sun, electric bulb. So these are what is luminous object because they produce light. So that is why this is known as a luminous object. So here we take a plane mirror for the study of a reflection. So basically plane mirror what? So that back surface coated with the some materials. So that is known as the plane mirror. So their shape is what is plane. Other mirrors also possible, that is known as the spherical mirrors, and these spherical mirrors are divided into two types, convex and concave. So first of all, here we take an example of a convex mirror whose back side coated with a black material or a red materials. So here what four phenomena. So first phenomena, what is reflection of light, and second phenomena, what is the refraction of light. Refraction of light. So for reflection of a light we take a plane mirror. So this is a plane mirror whose back side with coated. So that is back surface coated with materials. Okay, and this is what is plane mirror. So this is plane mirror and this is coated with the what is materials, and here take we perpendiculars. So this is a perpendicular and that perpendicular known as what is normal. Okay, so we write here this is normal. Okay, and here we take a source of light. That source of light generate what light, and that light travel in a medium or a vacuum and comes at the point L. So we mark this point what is L. So this point L. Okay, so we write here this is point L and this is a torch. So that produce light. So this is a light. Okay, so this light which fall on the surface of a plane mirror and point this is point L. Okay, we mark here this is point L, and this light make angle with a normal. Okay, so this normal what is N, and this is what is source of light, source of light, and this known as what is incident wave, incident ray of light. Okay, after striking the incident ray of light at the point L, then what happened? Then ray of a light bounce back. That is known as the reflection of a light. So this bounce back light known as what is reflection of a. So we make here this line. So this ray strike on the surface L and bounce back. So this bounce back what is known as the reflected wave or a reflected ray of light. So we write here bounce back light called what is reflected light. Okay, so this phenomena is known as the reflection of a light. So here important, this ray of a light, we mark this is EF. This ray of a light EF. So this make angle with the normal. This is normal N. So this angle what is I1. And this ray of a light, for example, this is EF, this is CD. So this ray of a CD make angle what is I2. Or we simply sometimes say that is R1. What is this? R1. So this is your choice. We called this I1, I2, but for simplification, we name that I1 and R1. So what is here I1? So I1 what is angle of incidence? Angle of incidence, okay, between normal and incident ray of light. Okay, and second, what is R1? This is angle of reflected light and normal. Okay, so we can define this phenomena in one line definition. What is reflection of a light is the phenomena of return of the light in the same medium. So when the light strike with a plane mirror, so it bounce back. That phenomena is known as the reflection of a light. And the second important things, but this incident ray, this normal and this reflected ray are lie in the same plane. What is? Lie in same plane. Okay, so this is important. Lie in same plane. And one more things, I1 is equal to what is R1. So it means angle of incidence always equal to angle of reflection. For example, this angle is 60 degree. So this angle also 60 degree. So this is known as complete what is reflection of light and its law. And second phenomena, so this is first phenomena of a reflection of a light, and second phenomena what is refraction of light. So refraction of a light basically what? When light going from one medium to another medium. What is here important things, what is one medium to another medium. Here only same medium. So this phenomena in only air. Here we can take two phenomena, air and the glass, air and the water, air and the oil. So that is why when light going from one medium to another medium, it bends away the original path. So for example, how we explain this, we take a example of a glass slide. So we take a slide, glass slide. So this is a glass slide. Okay, and this glass slide taken, that is rectangular glass slide, and we take a normal. So we take here, this is a normal. So this is normal. Here take a incident ray. This is incident ray, and this going from here to here. So first of all, write a name of that. So what is name? So this is what is glass slide. Okay, and this is what is, for example, this we mark, this is EF, and this is what is source of light, light source, and this is what is normal, this is point L, and this is glass, this is what is incident light, Okay, so what happened when light comes from the sun from point the L? So what happened here? What is air? So this is a air medium, and this is known as the what is rare medium. Okay. So what happened? Light going from here to here. So when light going from air to glass, so what happened? It is original path. This is original path. It bend toward the normal here. What is it bend toward the normal? Here we draw another normal. This is normal N1. Here we draw another normal N2. Okay. So this is what, this ray is what is refracted ray. Refracted ray, and this is glass. This is known as denser medium. Okay, and this is normal. So this normal what is N2. So here light going from here to here and strike this point. So this point, for example, this is M. So here light going from glass to air. So again, this is what is air, this is glass. So when ray of light going from denser to rare medium, it bend away the normal. So how bend? This bend like this. Okay, so this is what is refracted ray. So this is refracted ray and this is original ray. So if you draw the path of a original ray. So what this is path of a original ray. So this is what is original ray, and this is what is refracted ray. So what is the difference between path? This. So this is the difference between original and the refracted path. So we can find by drawing here a normal. So we draw here a normal. So this path we can measure by using scale. So if you measure by using scale, so this path is how much? 2-3 centimeter. So we can say refracted ray refracted how much? 3 centimeter from the original path. So here one important things, when incident ray comes and this is normal, they make a angle. So this is angle known as the angle of refraction or angle of incidence. Angle of incidence. So this is what is I1. And second, here make a angle. This is known as R1. So this is what is angle of refraction. Angle of refraction. Okay, so again make here this angle I2 and this angle what is R2. Sometime this angle known as the angle of the emergence. So this angle and this angle should be equal. So we mark this angle and this angle must be equal. So I1 is equal to R2, that is known as the angle of the emergence. So this phenomena is known as the what is refraction of a light, and this phenomena known as the reflection of a light. So here what is important, when light travel from air to denser, so it bend toward the normal, and when light going from denser to rare medium means glass to air, it bend away the normal. So we can find all angle I1, I2, R2 using D, and we find out this distance by using scale. So this phenomena is known as the refraction of a light, and this is known as the reflection of light. And other things, reflection of a light in a plane mirror. Reflection of light in plane mirror. So plane mirror means there are two spherical mirrors. So this is plane mirrors, and other things what is spherical mirrors. So spherical mirrors, they have shape of a sphere. So that is why they are known as the spherical mirror, like a hollow sphere. So if we take a hollow sphere like a plastic ball that are empty from inside, so when we cut into two parts, so that acts as a sphere. Like example of we use spoon for the food, so that spoon acts as a sphere. So spherical mirror are two types, that is convex and other is concave. Okay, so convex what is, we make so this is what is so this is what is coated surface. Okay, and this is what is reflecting surface. And here in convex, this is what is so this is coated surface, and this is reflecting surface. So basically convex mirror are what is, they are thick at the middle and the thin at the corner. So here we take example of a reflection. So we take, for example, this is a pole and this also what is pole. So when light come here on this surface, like this is a incident ray. So here we do normal. So these are what reflected by this. For example, so if we draw here a normal, so it is reflected. So this is reflected light and this is incident light. So this is the reflection of a convex mirror. So here we take, this is a incident ray of light. So after reflection, it going this. So this is the what is reflection through the spherical mirrors. So convex spherical mirror and second is concave mirror. Okay, so here in plane mirror we already studied the reflection of a light and some characteristics of the plane mirror. Plane mirror always form what is erect image. What is image formed? What is erect? Erect means straight image and what is same size. And third, what is size of the object, or we can say distance of the object. Distance of object from mirror is what is same as image distance from mirror. Okay, so we take, this is a plane mirror. So here this is a object. So this object seen behind the mirror here. So this is what is object distance u and this is what is v image distance. So here what is u is equal to v. And second things, this is height of the object h. So this also same. So h dash. And image what is virtual and erect. So there are two types of the image form. One is virtual image and second what is real image. So basic difference between the virtual and real image. Virtual image, that is fake image or we cannot obtain on a screen. That is virtual image. And when we talk about the virtual, then we connect what is erect. So virtual image always erect. And second, if we talk about real image, so real image what is inverted image. So when real word comes, so connect inverted. So real image always inverted image and real image can be obtained on a screen. So this is the basic difference between the virtual and real image. So in plane mirror and in the spherical mirror, convex and concave, so they form both type of the image. So this is the basic idea of a reflection through the spherical mirror and the plane mirror, refraction through the glass slide, and third things what is scattering of light. Scattering of light. And fourth thing what is dispersion of light. Dispersion of light. So what is scattering of light? When ray of a light strike with the object, so it scatter in the different direction. So this is known as the scattering of light. So we say that when object strike with objects, that is objects like particles, particles, then light scatter in different direction. Okay, so this is known as the scattering of a light. And next, what is dispersion of a light? So when a white light is passed through a prism or some prism-like material, then it divided into the 7 colors. So when light is passed through prism, it disperses in 7 colors. Okay, so dispersion means so we take an example of this prism. So this is what is prism, and we take a white light. So this is what is here, a white light comes. So this white light when passed through the glass prism, so it divides into 7 colors like this. 1, 2, 3, 4, 5, 6, and 7. So these are colors known as the vibgyor, V. So what is V, I, B, G, Y, O, R? So vibgyor means what? This is violet, indigo, blue, green, yellow, orange, and red. So basically what happened here? These divided into the 7 colors. So these 7 colors are known as what is vibgyor. We can remember by this vibgyor like this. So next is what is yellow. And after that what is green. And after that what is blue. That is sky blue. And after that what is indigo. So this is known as the dispersion of a light, and this is known as the scattering of a light. So sometime what happen? Color of the sky look blue color. So why color of sky look blue? Because wavelength of a blue color is less. What is here? Wavelength of a blue color is less. So if any light whose wavelength is less, then it scatter more. So basically what happen? Many particles present in the atmosphere, so that is lights mostly color which scatters, so blue color scatters in large amount, so that is why our sky look color blue. But when you look from the planet or a moon, so sky look black, because in space there are no atmosphere. If there are no atmosphere, there are no particle, it means there are no scattering. So that is why we use red color, yellow color, green color in danger signal like railway, because they do not scatter. So they look from the large distance. So we can say wavelength of the red color, blue color is high. So in next topic we discuss about the refraction of a prism. So thank you very much.